All right, we are live. Hi everyone, I'm really excited to host Raj Adiraman. So I have been following Raj's update about tech development at Sasaki for a while, and also like through Scott Penman's, and like they are doing amazing work. And I thought I should host him to know more about like how they are working, what are some tech developments, and even like I read the publication published by Sasaki. They have like great projects. So I'm really excited for this interview. Thanks, Raj, for coming on the show.
Yeah, thanks, man. Yeah, it's been a journey, and yeah, I mean, it's just so nice to meet you, on social media, and then have some interactions. And yeah, thanks for hosting me today. I mean, really excited to have very interactive conversation.
Okay, so Raj, can you tell us about your professional journey? Because like you come from like a technical background and you entered into AC. So how was the whole journey?
Yeah, I get asked this kind of questions, pretty often whenever I meet people in the industry and outside. Um, it's quite interesting because my undergrad was in computer engineering. That's what I did masters. There's always like some kind of a connection I felt, with places and like urban development and those kind of things. But that's the kind of small spot I had. I mean, like that's how I got connected with those kind of industries, and then but once I started working at Sasaki, there's so much of motivation around because working in different disciplines, as you may know, working in the same industry, so you get to meet a lot of people with different industries, in the sense that planning and urban design, architecture, like interiors, but then I think the real the motivation was the intersection of the tech and also the our planning and design industry, right? I mean, that's the kind of the junction where I found a lot of interesting things to do. Yeah, as you were saying rightly, coming from a tech background, yeah, initially there were so many things to learn, in the sense that I mean we pretty much learn every day, right? But then having the tech and having the right motivation kind of led me to pursue career in this industry and so forth.
I see. And like it's 10 years you're working at Sasaki, so that's like a great amount of like working. So like how what are like some major differences you find when you started out 10 years ago versus now in the tech aspect at Sasaki?
No, that's a great question. I mean, if you ask anyone in the tech industry, they'll definitely say that you got to. I mean, I guess it's the same in every industry, but then in tech, it's very relevant in the sense that you need to things are very constantly moving, right? There's no static or there's no stagnancy anywhere. So you got to be ready for things, when things changes, but also keep keep on the research factor in mind, keep on the research going on, whatever the time you have, and see how things can transform. But in specific to Sasaki, I mean, yeah, it's a journey, I would say, from where I started. Even in terms of technology, right from software development, I guess the medium is still the web and all this kind of stuff evolved a lot. I mean, we can do a lot of things in the web, from looking past 10 years back, right? A lot of this GPU intensive things, all this kind of thing. So yeah, I would say it's a lot of things have evolved so far in the last 10 years in general in tech. But at Sasaki, we constantly strive to, as I said, keep the research factor in check. So and not falling behind to anyone, be try to be a pioneer in that, and then and spread that across to any platforms we deal with.
I see. And when I was looking at the website, Sasaki has very diverse specialization areas like civil engineering, computation. So does your group fit like fall into like competition or technology group, or it's like a separate software development division?
Right. No, that's a great question. So our team is called like strategies. We are a team of designers, planners, analysts, and software developers that works at the intersection of research, innovation, and professional practice. Right. That's kind of a nutshell. But then we believe the informed design is actually better design. So we try to be more informed. We develop like new systems, tools, and visualizations that allow us to ask the right questions, right? And then reveal deeper insights towards a better design. So yeah, we are positioned in a way that we kind of function as kind of a gear towards the rest of the company, right? In terms of problem solving, and then better design in terms of like developing these kind of products and tools which can be used in a lot of our projects, like in varying projects, whether it's like planning or design or construction, administration or architecture. But in terms of like, there are also like other few smaller groups in terms of like computational design. Those kind of things we really work closely with them. And having said that, I mean, we also have like computational designers in the group. So yeah, I mean, things keeps us busy, pretty much most of the times, because working with like different people in different disciplines pose its own challenges, and that is something like we try to put our maximum potential to solve the real world problems.
Got it. And like, so in that group, like there are like people with data science, data visualization, ML, software development. So like what aspect do you find most challenging as part of your work?
Yeah, yeah, maybe I should tell a little bit about like what I do on a regular basis. So yeah, I'm a tech lead at Sasaki. Within the strategies team, as I said, like our team is like a mixed group of people with different skill sets, and I foresee like technological things in terms of like app development, developing a product from scratch to the end, and also kind of manage the team a little bit. So yeah, I mean, like 50% of the time is usually I spend a lot of time like coding. Whether it's like any platform, any tool, language, doesn't doesn't really matter. Within the rest, I focus. There are like a bunch of different things I do in terms of like research. That is something like, as I said in the beginning, we as a company, we encourage that. So like every Sasakian, as when you talk to them, they will definitely speak of the research aspect. Yeah, apart from the research, as I was saying, talking to this different people inside the team itself, trying to understand this cross skill set each person is having. It's also a learning process, right? I mean, like because trying to get a better understanding of like what the client's expectations, or maybe the internal team's expectations, and then sit together and then like brainstorm about the ideas, those kind of things. Yeah, I mean, we in our group, I mean, like anytime when we start from scratch, we always going to the drawing board, right? Like okay, so these are all the things we have on the board, and then like how do we want to approach this problem, right? Yeah, it's a very organic process, I'd say.
Got it. And like, I'm curious, it might be like challenging to provide a concise answer, but can you provide us like an overview about different projects the group have done till date, and like maybe some highlights?
Yeah. I mean, there are like I would say, I mean, in terms of projects, I mean, like it varies across a different scale. As I was saying, you can split them across like different disciplines, like planning, design, architecture, those kind of things. But if you want to like categorize a few things, I would say mostly like we have done like a lot of this engagement products, which can engage with the people, and then like spatial analysis projects, data visualization, like dashboards, and then like virtual reality, and also gamifications. I don't know if that falls into that kind of a broader aspects. So that is in terms of like the types of products or tools we develop in the strategy team. But if you talk about as a firm on a whole, then I would say as I was saying, like different disciplines has different needs. So we cater for planning or design, etc.
Got it. Now I think it would be like good to like go deeper into one of the project you develop, and if you can provide us like a start to end, like talk about like the process of developing that project.
Yeah, sure. Yeah, one other thing I was thinking, like before maybe diving into the project, maybe I think your last question, as you mentioned, it needs a little bit of time to actually uncover a lot of things, because it's really tough to put everything in a nutshell. So I was thinking like maybe if you have time, I think it'd be great to spend like just a few minutes to uncover like what are the range of tools we develop, and then maybe after that it would be a nice segue for us to jump into the one of the research projects, which I'd be like really glad to go into detail in terms of like like the machine learning aspect, or like what kind of tech stack it has. Yeah,
For sure,
good.
that's a great idea. Yeah.
Okay, great. And yeah, I mean, please let me know if there's any questions. Don't hesitate to stop me and interrupt me and ask any questions. So I'll be glad to answer that. So I'm going to screen share. It's fine. All right, so are you able to see the screen?
Yep.
Okay, great. Yeah, as I was just saying, we strategist team has this kind of very, this even doesn't do it justice in terms of classifications. So there's still a lot more, but I think I try to put them in a nutshell in terms of like what are the different kinds of tools or products we develop. So like engagement websites or engagement activities, spatial analysis, data is just like some key aspects in terms of seeing some challenging data in a visual format, and then like dashboards, gamification, and then virtual reality. So yeah, I'll spend like super quick time on each of these things, and then see like what kind of things we develop, so that it will give us and the audience an idea of what some of the things we do. So this tool is called CoMap, which is called collaborative mapping. It's a short form for that, for CoMap. So this one, as you can see, it's a web interface. I just like try to make a small video of it. So normally this has been given to like campuses or like urban areas, like whatever the city council or those kind of people, and we let the audience take these kind of graphical surveys, if I may call that. So people, like drag or drop their icons and routes, at different places, and then try to, come up with, like, I think like this is one of the things which gets close to the people in terms of, we do ask like, where do you bike, or where do you eat, how do you commute to your campus, those kind of things. And in general, it tells us like, like once this has been taken by like thousands and thousands of people, right? You get you can like visualize them in a format so that it's just like pretty great in terms of like see a pattern or something. So this one, I think I would be fair to actually go into the website directly. So this is something like an engagement website we developed. The timing of this is like pretty great, because this has started like when the COVID has started, right? This is like an in-person thing. Our team usually travels to the the plant space, and then like come up with these kind of things. But during the challenging times, like no one could really travel, so we wanted to come up with kind of an engagement website so that people can interactively like or feel that they are in the campus, right? That's what we come up with. So I'm going to jump to that super quick and then see how. So this is the website as you can see in the slide. So as you keep moving, kind of gets you a feel that it kind of takes you to the campus. So there's an interactive piece in it. Like for example, you try to answer, like whether it's you're an undergrad student, and then then based on what you answer, it takes you to kind of different options, as you navigate in the website. And also on the left side, as you can see, there's like a kind of a point system, we maintain. So as you go down on down, that kind of fills you in and gives you an idea about each sections. Yeah, like things about where does this kind of things exist? Because the freshers are someone who really may not be aware of all these things. And then you can answer these things like based on like some kind of rating, and then you can submit, and it kind of shows you like instantly like how many people have answered this, and what you have answered on these kind of things. Like if you go down and down, then again it's very informative, but also at the same time super interactive in the sense that this is like an informed decision making. Saying like how on academic life on campus is getting affected, right? So these are as you can see, the sparkling things. So those are actually the, as you can see on the right hand side, these are the class schedules which happen in different times of the day.
So like, is this like an onboarding experience for like freshman students, and like, is it for like students to experience the whole thing, or architects are using this data for like as a user engagement, like user research?
Yeah, great question. It actually serves both purpose. Depending on who the audience is. As you rightly said, like if they're a student, like it's kind of also really knowing about the campus. So that is one thing. And then like if they already know of the campus, we ask them like a few questions upfront, saying like how do you like the space, or how do you experience the space, those kind of things, and maybe tell them to rank those kind of things. And then in terms of the other aspect, for people who are more like architect or planners, designers, those kind of people, that for them it will be very informative. Like in terms of onboarding, yes, I mean it depends on who is actually using it. But yeah, I mean this is more like for like it's an open house. That's like the main purpose for it.
Mm-hmm.
Yeah, so let's jump back where we are. All right, so this is one of our past research projects which we had. So parks and equity is basically about, as you can see here, this is a tool we made out of it. We studied parks across the whole US, but we focused, largely on like LA, the surrounding places. As you can see, it's more about, the equitable nature, like when you play with this kind of scenarios, like, how things get affected, are you meeting the population, the local population, closer to the parks? Is it something enough for people, to avail the park needs, right? I mean, like, because in some places the parks can be super crowded, right? Again, it's purely research, but again, the data for this, it's pretty much we collected across, there's a lot of groundwork into it. So apart from in terms of mapping, it's all like OpenStreetMap and those kind of things. But in terms of data, like our team actually went on, collected all this parks data, like from an RPA, and also like going to the local parks and like getting all this like data. So and then also like clubbing this with census data made it more rich. Again, like there are like few facets in this, but this is just like showing like one aspect of it.
Nice. And it looks like data collection is like a huge problem sometimes in developing an interface. So are there like some lessons learned or insights from this exercise?
Yeah, that definitely is. Great question again. Yeah, I mean, It's always a challenge to get the data. I mean, like, first of all, getting the data itself is a big ask, especially like public data. But then once you get the data, how do you prepare the data, right? I mean, that's the other part. That's like, yeah, I think I would say it's a tough thing to kind of address in terms of because that's, I mean, it's also having this as a research project really made us ask a lot of questions. I mean, there are some cases we don't have data, right? I mean, like that's how it works. But then but once you're better equipped to take the next step forward, then you're able to get those data. Yeah, I would say it's a challenge, but I think I think in this case, like especially getting international data was really tough. That is something like I would resonate with my research project, which I'm going to show in a bit.
Mhm.
So this one again, this is like this is in like South America, a place called Las Vegas. This one, they had a really complex problem of, as you can see, it's along the shore. It doesn't really show like where it is. All this like greener things. It's close to the beach. So our client was basically trying to build this kind of array of apartments for both commercial and residential. It was really tough for them to see all this kind of different viewing angles in terms of like from the ocean front or from the other side of the top down, and especially like once you start building it, like as you can see here, like how you can control these different factors. So that was really challenging for them to have a single interface and see all these things, like how much money you put on this thing, and then like maybe change your square footage, and then how it affects the overall cost or overall construction development. It's quite interesting. I mean, like it was quite challenging to put together something like this, I would say, but yeah, as we're saying, that is something like we constantly try to address and challenge ourselves in terms of like how far we can go.
Yeah. So this looks great. Like I'm just curious, like is it what's the tech stack? Is it like the model is done and like it's rendered in 3JS and the interface, like those functions are like calculated, or it's like API which is calling it?
Yeah, great question. So this one, it uses like WebGL. WebGL as like it's an underlying thing. It's great in terms of using graphics in a browser to illustrate any changes which you can see, which is easily grasped by the web interface. In order to highlight all the things, we made this kind of animation to see like how these things work. Yeah, apart from WebGL, it's all like browser based. Of course, 3JS, but yeah, in terms of like language and stuff, it's all like JavaScript. It's all like browser based here. There's nothing really outside used. Like, I mean, even for hosting things, we pretty much hosted like S3, like as on AWS. But yeah, apart from 3JS library and using this WebGL, I don't think there's anything like too much outside of it. Yeah, and we are right now trying to move towards React. For this one, I mean, like our current system are pretty much all like React based web apps or websites. This one was slightly older before the React came, so we're trying to constantly move anything which is being currently used move to React, like framework.
Yeah, that's another part of the tech challenge, to constantly upgrade with the new library versions. And
Exactly. Yeah, so moving on. Yeah, I thought it would be nice to show the Space Moves. So this one was in Rutgers. So as people in the audience or know, like Rutgers has this kind of different campuses across this Jersey. So yeah, one of the constant challenges they had was this space moves, right? In terms of also like the students and the professors, they need to sometimes like travel back and forth between these campuses, right? It was not like highly efficient. but they want to address the challenge. How far they can reduce the space moves, and then as far as they can minimize that, and then make it efficient for like both space utilization and also reduce the traffic of movement of people. I'm going to quickly play that. We call that as like swarms. So it's funny. It kind of looks like a swarm, but as you guys can see on the right hand side, as the animation goes off, things constantly move back and forth. And then what you see on the right side is how many number of trips people take. So that you see that in a given amount of time, pretty much during the day. This is across like the whole think calendar year, I think, but I think even in a day, as you can see there, like how many trips like each person takes. So
how do you use this data for like decision making or planning?
Yeah, great question. So I think getting the data to this part itself is a tricky thing, because often, as you know, like in campus world, getting a good data is always a challenge. It's a constant thing. You need to be be in a constant conversation with the client and see if you can get real data. But in terms of once you get the data, I think it's pretty much up to how we wanted to visualize it. This is not like a web-based tool. This one was like more like a packaged executable file. I don't know if Gephi, the Gephi platform. So that's what we use. We call it as like spatial Gephi, which pretty much worked in our favor in terms of because it took care of like things like system requirements and all these kind of things. But yeah, like the data is kind of packaged in a way in this executable. So it's all like JSON format, and then once it's there, you're able to like parse them and then use it based on different needs.
I see.
Does that answer your question?
Yeah, like I was curious, like so I understood like the data challenge and like the visualization platform is great. So I was thinking like the use case, like once the data and visualization are done, did it help better in like transit planning or like building placement? Like what was the end use?
Right. Yeah, the other side of the thing, definitely yes, because previously before we had this basically we don't, at least the client did not know like what was really happening behind the hoods, right? Because this is like one aspect of the tool I was talking, but more often than not, there are a lot of things happening behind the scenes, and also like like different filters applied to it. So it kind of, in the end, they kind of made the client really aware that like these like they were able to quantify things, right? Per day. Like there's so much movement happening between these different campuses, and then also like in terms of utilization, like how better a classroom has been utilized, right? So sometimes it's very undercrowded, so those kind of things. I think there's also like other aspect of this tool where you can actually export this kind of data. So that really help the client really narrow down a few things, and then like take those informed decisions in their master plan process.
I see. Yeah, and I think like even the visualization is like quite provocative. You start making like realizing, okay, this cluster is like more busy at this time period, so should we rearrange the classes?
Right. Yeah. Then I think like one more super quick thing. So this one, as you can see, it's a dashboard. So before playing on this animation, or maybe I'll play it so that's easier to grasp. So this one, again, it's a master planning process for any campus. This is for University of Connecticut. So what you see on the right side here, it's basically like a project timeline, right? For all the buildings, as you see on the left side, the bird's eye view of the campus, how different planning process affects the buildings. Some are like renovation, and some are like new buildings going to be constructed. Some are like going to be demolished. So it's really tough to foresee things without some kind of a visual tool. As you can see at the bottom, it's all about informative charts. Like how when you change a project timeline on top right, how things get affected. You need like more beds, right? For certain rooms, or like how much the construction is going to cost for that. And as you can see in the middle chart, when you change something based on the timeline, how the construction is going to cost is going to increase, because based on square footage, it's going to be different cost for different places, right, or different buildings. It was something interesting in terms of for the client to see something like this, because it's again like a constant challenge to solve a problem like this. And again, we are also like in terms of tools, we're also improving this to take it to the next level in terms of the other rich features which we add.
Yeah, I love this because like it's so like real time. You move it, you see the change, you can make like decisions on the spot. So just curious to know like the tech behind it. Is it like using Power BI, or like how is the 3D and the 2D data being related?
Great question. We often ask a similar questions before when we show it to someone. So yeah, so this one, it doesn't use Power BI or those kind of things. It's something we developed from scratch. So in terms of framework, it's all like React. In terms of all this kind of timeline, the charts and all these kind of things. The charts are coming from a React library charts, and then timeline is something like we build. So as we kind of build this tool, it's something we kind of decided a few years back that anything when we develop in this React world, it has to be like more components based. Something like in terms of modularity, like reusability. We want to adhere to this kind of best practices so that we are not like reusing the same thing again and again, or those kind of things. But yeah, in terms of the stack, it's pretty much React. All these components which we made are all are like reusable. But what you see on the top left, that's a different thing in terms of that, as you can see, that's a pure image. But then those images kind of has the intelligence of or I would say like the app has an intelligence of connecting the different parts of the image with the different components of the app. That is something like we came up natively in terms of React, like building the components which can connect different pieces.
I see. So is it like when you move the timeline, like, and if in the image it will check whether the building exists or not? If it exists, like the opacity will dependent on the property.
Yeah, something along those lines. Yeah.
Okay.
So things like for example, if you need to be specific, as you move this timeline, right? So in terms of the app, all it knows is like the green one, the gray one is like one project, right? And then each project has different phases, like Q1, Q3, and Q4 in a certain year, and then it can span across like different years, right? And then in terms of image, the image has like different components. So each project is like you can literally equate it like a building, right? So each building is like each project, as you can literally equate that. And then once we made the connection, it's all about like playing with this inside the app, changing certain things in a project, because a project can have like different attributes. Project has like a timeline. Project has like different phases. Project are associated with cost. All these different features. So it's all about like connecting those. I would say some metrics and features of a project with different components.
I see. And
Yeah.
Daniel, sorry.
Go ahead.
Daniel has a question. Is the data live stream? I guess like with real time, does it update or?
Oh, it does. Yeah. I mean, yeah, we have it's all like web based. Yeah, I mean, there's nothing. This animation is just like in terms of to show in a nutshell, like what happens, in the app. Yeah, we have like a login system for that. Once you log in, like you can load like different scenarios as you can see on the top. It's just something like scenario 3 final, but you can create your own scenarios and or like open a different scenario which you already made. But yeah, in terms of all these changes, it's all like real time. Actually, that's a great question because that's a challenging thing in terms of like um, getting this app really smooth, because once the number of projects increase, you're asking a lot of things to do with the app, right? So because it's all like web based, and then there's so many things happening, behind the scenes. Sometimes, one of the challenges we faced was, sometimes it can be really sluggish. So, I mean, to be a little bit more specific in terms of the tech stack, I told like React, right? For the state management, we started to use MobX. MobX or Redux is a very common thing to use. But in MobX, then we kind of saw that there are some kind of limitations you face once you go deeper and deeper in terms of like maintaining these kind of observable states. So then we kind of have to move towards like like TypeScript, and then like the MobX Keystone, those kind of stacks, which helped us to make it more efficient.
Got it. And like last question from my side
Yeah.
is, so how does like do you like envision like project architect using this, or construction manager, or client, like who is like making these decisions? And
So in terms of the non-tech side,
yeah, like I was thinking like, okay, once we have this tool and we can try out different iterations and like scenarios, like who is ultimately like using this tool? Like is the like
right,
developer, or
I got
project
it.
architect, or construction management firm?
Yeah. So the use case of this is they're like our client are basically like campus folks. Inside them, it's all about people who are involved in the master planning committee. I mean, they involve like planners. They have like inbuilt planners for them, and also other people in terms of like chancellors and like discipline heads and all these kind of things. But I would say this particular tool has been developed more for people who are involved in the financial aspects of master planning, because they need to know, like, once they start a project, once the phase of the project is getting affected, how cost-wise is going to get affected. So that's one of the main themes, I would say.
Gotcha. It's amazing.
Yeah. So then moving on, some more fun set of things. So this one, we did. This is actually doing a Scrap event we had a few years back at University of Washington, UW, Seattle. So they had like a 3-day event, and then they wanted something like a phone app which can they want the people to go around, right? Not be static and not sitting at one place, right? So that's the main thing. But also to explore the campus. So something like the Pokemon Go, right? I mean, just like super race, people collecting all the gems and all this stuff. And so we built this app. It's in Play Store and App Store. People can download it. So the basic idea is that have your phone in your palm, and then go on the campus, and then as you can see here, the W's, which is like the university's main emblem. As you go near that, then the phone is going to display what's there, right? I mean, maybe it's a building, maybe it's a fountain, or maybe it's some iconic place in the campus. Then you're collecting all these gems. As you can see, there's a small husky puppy here. Maybe not too much visible in the dark, but that's something which comes with you as you go on the campus. I think people loved it. Actually, we made it like a little bit more fun in terms of like people are going to collect more gems, are going to get like prizes. And then we gave some 3D printed. We have 3D printers of at our farm. So we 3D printed like all the husky puppies, and we gave them as like some kind of a souvenir, just to make it more fun. Yeah, again, yeah.
No, no, I was just about to say like so we can use this for scavenger hunt.
Yes. Yeah, no, definitely yes. That's one of the ideas. But yeah, I mean, in terms of testing it, I think like there are a few challenges in terms of because this works. I mean, this has to work in that geospatial region, in Seattle or something. Right? Then how do you test it when you're developing a different place? So we kind of did a simulation, in Boston, where our firm is. And then we went around, we made a simulation place with all these like different places and gyms. Then finally we were able to test it and put it in production. But it was a fun thing to get on this one.
I see. And like I'm curious to understand the workflow for this app. So let's say you install the app and then it calls like a map API, and you add objects which are like geo tagged. So do you add it in your database and then connect to the database to the app and then it reflects? Like how does it work?
Right. So one thing I want to mention is like we developed this as app using Unity, the Unity engine. So in terms of Unity, as you know, it's pretty visual in terms of app development. So in terms of map, initially we thought to go like real-time maps, but in our case, we didn't have the need. It has to be real-time, but it doesn't have to be like global. Right? It has to be only a certain place in a city. Right? So then, we had like map layer, and then it's all like as you can see on the phone, it's a very custom-made map. Like it's all like raster maps, which we put it on top of a map layer, and then using Unity, we placed all this kind of different W's in different places, and then we connected with the data in terms of each W or all this like symbols has different text and images associated with it. And there's another image which will do more justice in explaining that. But yeah, it's all like packaged together. There's no like external database or something. It's all like the only call I would say is which could be external is like more like the geospatial thing, right? I mean, once it goes beyond a region, I mean, once you're trying to use the app outside this campus or something, it will probably like say, okay, you're going outside your campus or something. But apart from that, I would say it's all like prepackaged. Yeah.
I see. So the reason I asked is like I was thinking, let's say during the app development you prepared for Seattle, and now after like a couple of months you decide you want to add another city, Chicago. So you do need to do like an app update, or you can like have like some API which can automatically add more features.
Right. So yeah. So that's how we started. So I was saying initially we started if you need to be global, it's super easy. But then in this case, I don't think we just need to push like a different version of it, because there are like a lot of custom things in this, in terms of campus, because these are like specified landmarks. So if you need to like spin something up for Chicago, I mean like we need to get the data first, right? Because each location is going to have a different data. Once we have the data, it's pretty simple for us to make an update on that.
Got it.
Yeah, and then this one, it's a virtual reality. We're also like making strides on that aspect. This is something developed using Care Panel, and we switch that. But for example, we had all these amazing images. We had a dedicated person on our team, so who kind of works on this kind of thing. So stitching the images, and like you can also like go forward and like see how the space has been built. Then also you can go to like different places and you can visually see how the space is built. The one thing also like it works on mobile. Yeah.
So like looks like so it's deployed on Amazon server, and like you have uh like a web-based like interface like for like client walkthrough or like spatial walkthrough. Yeah, I think you're mute. Yeah.
Yes. Yeah, you're right. So that is one of the things we had. Yeah, spatial walkthroughs is something like key aspects we thought. Yeah, in terms of hosting, as you can see, it's on S3. It's pretty simple to spin up something like this. But I think like the powerful graphics is something like you need first to make this happen.
Yeah. And like, can you do like annotation or something? Like, if you want to do like, is it possible?
Yeah, of course. Definitely is. So you mean in this one or any other aspects?
Like, for example, like I'm just thinking like if we want to add more like features uh like annotate like this, like some with a pen or something on screen,
Right.
like how would you approach like adding more features on top of it?
Oh, for this one, yeah.
Yeah.
I think that's a great question again. Again, like when people see these things, this particular example, I would say it's pretty limited in terms of what you can interactively do. I mean, other than we have created the spots, which can click and like go to some region. But then there's another version of the app. I guess I had the link. So in that one, you can actually draw things on that, and it pretty much saves everything on the fly. And later on, when you come back, and then you can see, okay, so this is where new furniture should be coming, or this is where like a new plan should be placed.
Gotcha. And when you're like showing this VR, like does everyone like see the same thing, or it appears like a different instance on everyone's computer? Like for example, in a client meeting, like if I'm showing and if the same client opens the link, are we both seeing when I'm panning, or it's different?
Oh, right. In terms of multiplayer,
Multiplayer.
great question. Again, I mentioned like the other version there. So that is something like which has like multiplayer. Like, it can sense who's the other player or the other person who is seeing frankly and where they're located. And that is something which we did. But in this particular example, it's all like pretty much singular
I see.
answers.
Okay, got it. And sorry if I'm asking a lot of questions
No,
on
no,
this,
no.
but yeah. So like, how does like logically, like how does it work when there's a multiplayer aspect? Like, I'm like, is it like the same instance connected to different like people, or?
Yeah, I mean under the hood, it pretty much works like the like a chat client. Like like we all use Slack or like different chat systems. It's under the hood, it's the same kind of logic being applied to that. But how do you maintain that? How do you make it a little more responsive and faster? That depends on how you build the system. Right? Yeah, in terms of technology wise, I mean, it's all like maintaining something in the app so that the app knows, like, when another person enters that, there's a new person with a new name, with this credentials or something, and then they appear on the left hand side or right hand side, or wherever you wanted to see them. Yeah, I would say visually, that's how we approach for this particular example.
Got it. Makes sense.
Yeah, so with that, I'm going to dive into the research project, which I was saying. So before that, I'm going to switch off my fan. It could be a bit loud. All right. So sorry about the interruption.
No problem.
Okay, so to give you a little bit of introduction to this project, this is one of the research projects got funded by Sasaki. So To give a little bit of context, Sasaki do fund 3 research projects per year, research grant projects across different disciplines. A lot of teams compete, and then 3 teams usually get shortlisted, and then they're funded with that. So again, like varying aspects. Like one of the things which are showing, like Parks and Equity was part of our last year's project. Yeah, so with that, I think as we go along, we can see like what are the different aspects this project covers. But on a broader aspect, I would say it's more of how do you use like machine learning to create urban impressions, right? That's, I would say, it's a basic outlayer of the project. So as you can see here, we go to presentation mode, so it's full screen. Right, a sketch, right? I mean, everyone is familiar with this kind of thing, especially now in our industry. Sketch, starting with something familiar, which is for all the designers at all scales, right? That's the sketch. It kind of gives high value for the designers because that is something like which is very open, malleable, and very exploratory and playful, right? I mean, like anything from a concept. It kind of starts from the sketch. How do you create? Depends on your medium, right? Some people prefer to do it in hand, like using different tools for this kind of things. So again, as a design tool, the sketch conveys a lot of meaning towards it, right? I mean, in terms of it's full of information and storytelling potential. That's what a sketch has. However, like typically it requires knowledge of a specific domain, like more like architectise. I mean, I don't know if it's a word, but so in order to read it correctly. I think, as you can see here, without that knowledge, if you take the sketch literally, and present it outside the context, it can be easily misread, right? The red road is not red, right? So as you can see, the previous one, it was like a streetscape. I mean, this one is like, it conveys a different meaning here. So again, the rendering aspect, we have all this kind of great rendering, from, developed from the sketch, right? I mean, an image that appears complete often appears at the start of the design. So the fact that, they show up before any actual detail is resolved, suggesting that what's important about the rendering is not the details themselves. It's more about the aesthetic character. So the rendering, kind of makes explicit what the story is being told behind the scenes. That's one of the characteristics, which we normally see in any kind of this completed renderings, which is like, very rich in terms of the output. Again, this is like a, if you take a step back, from where we started, you have a sketch, and then you have this kind of middle phase with kind of a design, but bit of a graphic with it. Still like looks very graphical, but then finally you go to the rendering stage, which is like more like a completed design. How you might see things in real time. I mean, it may not be always it should be true, but I think in terms of concept design, at least it conveys that. So on the other hand, the image can be quick, loose, and focus on asking questions, right? I mean, we have this imagery on the far left, which is more playful and abstract, like very design focused. But on the right side, you have like this public facing, like finished product kind of thing. It has some kind of an aesthetic to it. Again, as you see, that's how the translations are, right? Where do you find this kind of what are the gaps between the spaces? That is something like the questions we try to ask during the research project. So I'm going to play a quick video, about the tool. We kind of it's in the process of making it. We're going to, again, I'm going to be quiet, and then we're going to dive deep into it, like once we get to the different parts of it. One thing I'd like to point out here is like, on the left, you can see an aerial impression, and then the right side, when a user sketch something out on a landfill land use map, how a new area has been getting generated, right? Again, I promise, like we'll look this again towards the end, maybe to go into detail, like actually, like what's involved in this process, and then it'll make like more relevance. Right? Right. So yeah, in terms of like again, machine learning, as we all know, like you see them in all the different aspects of life. So a quick first step is to some of the terminology here, right? We can use this, introduce our categorizations of ML in this project, and how we can classify things. So again, like we want to show like what are the different tools we explored along the journey, because I think one of the things which again in terms of the timing, which get a chance to put it here, is like we did a lot of groundwork in terms of like user interviews, and like also literature reviews, going through all this kind of research papers, and let's see what people have done in the same ecosystem, right? And then and also like doing these kind of research interviews really helped us to like we interviewed people in the industry, and and also in academics, to get a sense of what are some of the pain points, right? We need to be aware of, and because oftentimes like sometimes you go into a rabbit hole, which takes a lot of time out of you. Yeah, so I think it really helped us to shape our project in a better way, so that it gives a really a good sense of what's kind of involved in this, and like and also to narrow down like what exactly we're going to do. So this one, it's called Runway ML. It's one of the tools we started to explore. Again, during this journey, we also wanted to see what are the different algorithms and tools out there, right? I mean, like which can do something which we wanted to do. I mean, is there a tool which exists like that? So things like the Runway ML is a framework. I mean, or you can call it as a tool for that matter. It can be used by even non-programmers to kind of load designs, and then like generate sketches out of it, which can be pretty fascinating. I mean, as you can see on the left, there's like a Chicago riverfront, and then that kind of turned into like a Prisma-like image. The really interesting part is like how it gets the colors of the trees and in the water and people, different the color of the dresses. It's really fascinating to see something like this. And also on the right side, as you can see, the design, like how like different phase of a building get different color. That is something like in terms of like machine learning, it's like some of the super interesting aspect of it, what it can generate. So I think I mean that's just of Runway ML. And then Artbreeder, again, it's absolutely like doesn't have any knowledge of buildings, right? I mean, and they're capable to give some kind of character to those things. The buildings can be of any shape. I mean, doesn't mean that you're going to construct that, but it just gives you this flavor of how these things can evolve. That's what Artbreeder does. I mean, like once you give some basic input, it kind of generates all this kind of different designs for you. Again, just for fun. Again, like these are again like once you give this kind of things, then you kind of expect kind of output, which is going to be like different shapes and different aesthetics towards it. Again, this one more in terms of like beginning to see the examples, which is focused on architecture as well. Well, the results of this model are the best. They capture recognizable visual aesthetic. As you can see, some of the research of plenty of great examples. it's called like RTGAN, as you can see here. These imageries are, modified using pix-to-pix. That is actually something we use for our project. Really a quick way to visualize things. Again, there's no like right or wrong in this, because it's all like, what we're trying to see is, how it can make, give creative ideas for us. DALL-E, again, this is another really fun AI tool. People have probably heard about it. Things like, one of the most recent examples is that, how to generate this kind of novel imageries, right? They might not be perfect, but they're convincing enough to stir the imagination, as I was saying. And then another technique is like, how do you employ this multiple different networks for different purposes? All right, so with that, we want to come to generative adversarial networks, GANs. That is something like, I would say, it was like a very basic, like I would say, fundamental thing of a project, right? I mean, that's we use GANs pretty much in and out of a project to, in terms of, algorithms or like generating images, all those kind of things. So we can dive into detail. That a common analogy, I would say, is the design student. They may generate some work, and then the design critic evaluates that, evaluates the work, and then decides if it is acceptable or not, right? I would say, so the GANs are basically like, for people not aware of it, it's like two systems kind of fighting together to kind of see like who is performing better, right? But then in terms of analogy, I thought like it would be great to have something like this so that people can easily relate to it. And then again, like if the critic rejects it, the student returns back to the drawing board, creates a new and improved work, and presents it again. So this cycle repeats until the student is able to pass the critique standards. A little bit of deeper dive into the GAN architecture itself. So as you can see here, on the one hand, there's a generator who's the design student, and then on the other hand, there's a discriminator who's the design critic who evaluates the work. The training set, let's say there are like real images meant to train the critique, as you can see here. Yeah, so again, as I was saying, GANs are basically like two systems, right? I mean, you can see like they constantly evaluate themselves to get like which is better. So yeah, in relevant to our project, these are like input and the ground truth. Like there are like two images in terms of training sets, like two different types of images. Like one is like input, other one is like output. The input is more like, again, these input can be anything, but for our project, the input map is like a land use land curve map. That's what we used, and then the output, we want to generate like new aerial images. Right? Again, choosing the right tool and choosing the right data, so it's always like a, as we saw even in the previous examples, it's always like a challenge to find these kind of things, especially once you're doing things at larger scale, it's really tough to get this kind of data. I think for our research, it's critical to choose the right algorithm, tools, and data sets. Few of the tools which we mentioned before, like Runway Animal, Artbreeder, like Robosat. So I kind of divided these things into buckets. Then I think, as I was saying before, after we did the literature reviews and like user interviews, we were at this and tried out a few different tools. We were at this critical place of answering these kind of questions, right? Do we have enough data available to test? And then, can this process create this kind of novel and interesting outputs? Is it cost effective? Does it solve a business problem or business case problem? And then, is it open source, right? Because all these aspects come into picture for us. Again, to address that, again, pitch-to-pitch is something like, those who are not aware of it, it's an algorithm which kind of does this like picture-to-picture translation, as it's evident from this image. If you give an image in a certain format, like visually it can be anything. You can even give a picture of cat, or a picture of dog, or a picture of a mountain. It's going to convert that into a different image, completely different from what it gave, right? And that's something like as a fundamental algorithm we used for a project, in terms of translating one style of image to different style of image. As you can see, like, this is like all this like facade example. As you can see, you give something like a blueprint kind of thing, and then it translates to how a real facade can look like. So just a little bit of how in our use case, how we put use of GANs for us. So what has really happened, right? How the GANs are really tested and trained. The objective is to generate like new maps without much input, or in other words, to fill in the gaps without much detail. What we see on the left is how these images are trained, right? On the right, we can see how the new imagery is getting generated. To take a step back, in the training phase, we simply like pick a map style, what we need to train. So in this case, the training is this kind of pink and blue map, which we call. So that's like a very minimalistic map. It's like a basic street map, right? It doesn't have any context to it. It's like very minimalistic in design. So that's the input. And then the output is, what we wanted to generate is the aerial image. So what we do is we pick a map style, in this case, the minimalistic map, and then we convert that into an aerial image, as I was saying. So you give the training based on that, right? So when you give the algorithm, like the image on the left and the image on the right, you train them basically, if you want me to annotate, it's more like, this particular square tile means this, right? And then when you constantly train these things, it kind of understands, what is a tree, right? These blue lines are basically like streets. And then, these pink blocks are basically like building blocks, right? And then once it sees this kind of greenery, then it understands trees. So it kind of does that kind of training to understand that. And then again, as you see on the right, you can see how things are getting predicted. Again, like these doesn't look like, super crisp. But again, these were some of the images which we took from the start of the training, like once you give the training, and then you feed in some test data, how it looks. But what is an interesting aspect to this is, once you train a lot of this tile sets, then your output get really a much better quality. Again, this is like a quick thing, as I was showing. The epochs is basically like any point of time, as of in terms of measurement, any point in time. So as you can see, as you do like a lot of iterations here, you can see like how for a given input on the ground truth, how the prediction comes. Like initially it starts like really nothing, right? It's like really fuzzy, but then as you train for more epochs and epochs, things started to get better and better. Again, in terms of data wise, we trained like 2,400 image tile sets, and then like it went for like 150 epochs. Just like each tile, if you have like A and B, each tile set has been iterated over 150 times. Like to get all the nuances of an image. Right, and then these are the kind of the different data sets we used. I just want to put it out so that it's maybe useful for some people. As you can see, like Mass.js, Mapbox, HD, OpenStreetMap, like NearMap, all these kind of different data sets we use for this exercise. I think one challenge we faced was getting these kind of data, except OpenStreetMap, I would say. Like getting international data for some regions was like a little challenging, I would say, for our exercise. Again, right now it will be much evident to see how this translation happens, right? So that's the test input on the left. which is a land use land cover map, and then what you see on the right is its prediction.
Raj,
Again, yeah.
yeah, so when you say like data set, you mean like the satellite data and simplified? It looks like the test input is like manually labeled, or is it like automated?
Right. Yeah. The test input, is basically you can give any input, right? I mean, if I go back a little bit further out, yeah, here. Well, this is not an exact same example. So what happens during the training is you have this kind of two different images, right? One is how what you're going to test, right? I mean, so in this particular case, we're going to test this kind of pink and blue line maps. So when you're going to train that, you're going to train a similar map. It doesn't have to be exactly the same region or same location. As long as it's if you take like continental US, it has like different landscapes, hardscapes, right? But if you're in a city, I mean that's what we're going to uncover soon. How training at different places geographically affect the outcome of it. So yeah, to answer your question and to come back to this, once you train, in this case, the training is basically from land use land cover map to aerial. So in terms of what is the test input, it can be automated. So basically, for our exercise, what we did is like we chose a bounding box, completely a different region from what we trained, right? And then we had to generate like map tiles, like real map tiles, and then give it to our the machine learning trained model, and then that and then we wrote the script which can basically make those kind of translations, and then that took care of the predictions.
I see. Yeah, the reason I asked is because like from my knowledge, the map box data of like a green patch of land is one, but like I'm not sure if Mapbox also gives like a boundary of trees in that data set, like based for the corresponding satellite image. So I was just curious, like for each like tree boundary, like did you had to label it manually, or you like took two data sets?
Right. Oh, yeah. So, right. Yeah. We had a script. We had a script to actually make it. We had a script which kind of exactly you give any different style of map, whether it's like land use map or street map or aerial. We told the script to actually slice these tiles, right, based on a bounding box, and then all it does is basically slice them into exactly the same aspect ratio and same width and height. I think this one's like 256 cross 256, I think, in terms of the tile size. But I think the script, all it does is like, once you give a bounding box, it basically slice them in terms of different zoom level. I think that is one key aspect, because, as you zoom out, you may get more context, but you zoom in, then, the context become less. I think this one, somewhere might be zoom 17, I think. Yeah, if you want to we know the detail, but I think, yeah. But yeah, we wrote a script to actually do these things.
Got it.
Because I think that is one key aspect, because each image what you train, it has to correspond to the other one. I mean, for our exercise, because we want to generate this kind of urban impressions, so that's why we had this kind of map tiles for exercise.
Yeah, because like that's quite insightful, because like data collection is one thing, but data processing is like also like a big part of, and it will like affects a lot in the training and output. So yeah.
Exactly. Yeah. There's quite a bit of work went on that. So this one, it's, as you can see on the left, there's a new aerial imagery which has been generated for a land use land cover map, which is shown on the right. So the model was trained on Boston and applied on Worcester, which is like a neighboring city to the Boston. We can see here like how close the prediction compared to the actual satellite imagery, right? The housing, streets, open spaces, trees and shadows are like how they're generated. Again, it's not like super accurate, but it gives the ability to generate a new imagery for a given area. So some fun facts, like when we compare this to the original satellite imagery, the original satellite image doesn't have a lot of trees as it was taken during winter. But then the machine learning model was quite smart to predict the images with the trees and shadows, right? That's some fun fact. So yeah, what you see on the left-hand side of the slider is completely like machine generated. So it's nothing. It's not a real image in terms of the actual satellite, but you can see how close it is to a real aerial image. So urban fabric, that's kind of our main idea when we started this project. Like, how can we generate this kind of different urban impressions? We also wanted to show you like what aspects of the study which we did in this one. So what if we reduce the details of the test input, right? I mean, the last study we trained a land use and CoMap, as we saw in the slider on the previous examples, with some details. The idea for this exercise is, what if you reduce the number of the details, like, reduce the context? In this particular scenario, we trained the model on Boston and applied on Ulster. You can see how a minimalistic input can generate like new aerial imagery. Again, this is like a city to city. As you can see, the first column is basically like the ground truth, and then this test input, and then the prediction is in the far right. We want to try something different because we trained this model on a city and applied on a different city. Like how does like Tokyo can look if you apply it on London's fabric, right? And or how does like San Francisco can look if you apply Boston's fabric, right? So it's quite interesting. I mean, like there's no right or wrong answer, but like so curious to see how these things work. For this particular exercises, I mean, we trained the model on Boston and applied it on Barcelona. So some of the key takeaways are, as you can see here, the parking lots, right? How the parking lots are get interpreted. In the middle one, you can see how this row of houses are transformed into parking lots. And then in Barcelona, there are like tight street grids, right, which are not in Boston. So machines interpret them as like parking lots. That's super funny, right? The row of houses getting transformed into parking lots, like that kind of tells us something. Just a very expanded view on this. Few things to notice are, this is like a detailed comparison we want to make. Like what happens if you train the model in a reverse way, right? I mean, what happens if you train it on Barcelona and then test it on Boston? You can see how the housing pattern has changed. Things like the color, the texture, the spacing, etc. So one quick thing, right? I don't know how many people are familiar with Boston in general or Barcelona. So you want to see, what you see on the top is actually Cambridgeport in Boston. That's like Central Square in Paul, close to MIT and Harvard. A mile of walk on this side goes to Harvard. A mile of walk this side goes to MIT. But how the Boston's fabric, when you applied the Barcelona fabric, transforms the Boston, right? We call that as like Bostelona. Right. So what you can see here is like, if you closely look, there are a few things like the rustic colors, and then like the street grids, which is like pretty prevalent in Barcelona. Actually Barcelona. So I'm getting too addicted with the word Barcelona. So I think there's some there again, like there are some weird artifacts getting generated, but again, like the main focus for us is how a different city's fabric, when applied on a different city, getting transformed. So we want to also show this one again on a side-by-side comparison. What we see on the right is actually the satellite imagery of Boston, and then what we see on the left is this impressionistic novel imagery generated as a mix of Boston and Barcelona. We call that as a Bostelona. So again, you can see a pretty marked difference, right? I mean, like the street grids, and then the width of the streets, and then the top view. even the color, the texture, all these things kind of changed. Again, for the training, again, it's trained on Barcelona, and then we applied that on Boston. That's what we got, what we see on the left. So yeah, I think let's see if we can play. Okay, so coming back to where we started. So this is like a sketch tool which we developed. As you can see, sketch is such an integral part of the design process. As we start to sketch on a land use land curve map, we see this new aerial imagery getting generated. As you're drawing a green blob, it generates like an open space. When you start to draw like simple lines and rectangles, it starts to transform that into new streets and buildings, which is generated on the aerial image on the left. You can see like how interactively this works while you're sketching. You're drawing like blobs of yellow, and that is being interpreted as like low density housing. Quite fascinating. I mean, really to see that. So you're drawing these flat areas without much details, right? I mean, that's the key part. I mean, it generates like shadows and trees and textures. As you sketch or scribble these kind of green lines, then the machine interprets them as trees. It's figuring all the stuff by itself. Like we haven't really given them any details. It's all in the training phase. We could feel it could constantly engage with the creative process of a designer, while iterating rapidly, and create this kind of new impressions. The big takeaway here is like how machine learning is used to generate like this new urban impressions quickly on the fly. In other words, how does like machine learn to fill in the gaps? That's
awesome.
That's very much it.
Like great presentation. Like I loved the whole process, like from start to end. Like it was a great like to know, because like I have seen academic presentations on like GAN, but also like how like the industry did approach of like conducting it and developing the tool and useful like case. It's great. So
Thank you.
I have a few questions. So many times like I've seen like inference takes time for your input, and here like everything is like real time. So like how is it deployed? Like is once it's like for a sketch based tool and you have trained model, are you like calling it on some Amazon website?
Yeah, so yeah, to tell you about a little bit of tech stack, I mean, so these models are completely trained on CoLab, called CoLaboratory. It's in Google Cloud. Those are specially designed for this kind of virtual machines, like this kind of running complex algorithms. So normally in the training phase, we run them on in the CoLab, which takes like a few hours, I would say. Usually takes, depending on the input size. But normally for 2,400 images, for 150 epochs, I would say roughly takes like maybe 6 hours, 5 to 6 hours roughly, I think. Yeah, so that is run there. And then like in terms of web interface, that's the fun happens. That's the fun place. So again, you're super correct in terms of asking like how real time it can be, like how fast it can be, because so once the training process is over, because the training process, all the hard part happens there. It needs to get this kind of training, enough training to make some predictions. So once we actually train them, the model, we export a model, like an ML model. That model, you can imagine that like as a brain or something, like a small brain. And that model, it's usually in different formats, depending on how your web application can consume. And that model is kind of used in terms of in a web platform. So in a web platform, all you basically have is like, you will have like this kind of sequence of images, like map tiles. I mean, like, based on the bonds. And then as an input, if you go further back, might be better to go to this image to get a better understanding of that. Right, this one. When you again, this sketch tool is very impressionistic. This is something like the demo thing I showed. It is something like very much in process in terms of full-fledged production mode. But yeah, I mean, we tested a few cases. So all you give in real time is like this sequence of images of map files, like whatever you want to see. I mean, in this case, if I play it again, right, as it loads, once you have a bounding box, for a test case, all you're going to do is give this kind of sequence of images to it, and then the model kind of takes that as an input, the trained model, and then that model, once it gets a test input, then it processes it and then gives a prediction out of it. So in terms of real time, it's basically like as you sketch and sketch, the input is fed. The input is basically what you sketch, right? I mean, and then the output is basically the generated aerial. I would say, yeah. I mean, it takes like probably less than a second. Sometimes it's a second. It really depends on the size of the image. Yeah.
I see. So like every time someone draws it, loosely, it takes like a screenshot of that sketch, send the request to the trained model, takes the
Correct.
inference and read it. So
Yes.
so like how many, like what's the send, like how many frames per second are you sending the request?
It's actually 60 frames per second. Yeah, again, there's no like one, like, because the user action is basically like each time they sketch, I mean, it generates a new image, right? So we kind of set a hard limit in terms of like how much time you need to wait before you transform. Like, let's say, I mean, I'm going to pause it. Yeah, pause it. Yeah. So once the user draws a line, when do you decide that's like a finished tile, right? So each stroke, that's what we perceive in this, like each stroke, whether it's like it's a scribble or it's a drawing a line. So at the end of each stroke, you decide, okay, that's the screenshot or that's a square image, right? And that you send that across to the model, and then the model kind of gets the output, which you see on the left.
I see.
It's quite interesting challenge to have that, because because you don't know like when to decide what is a completed image, right? Because it's a sketch. Yeah, it's not a finished image or something. So again, like depending on our use case, you can change those variables. Yeah.
I see. And like I'm imagining like it's asynchronous, where every time, like if like function on web where you're making requests and it's loading
Right.
all the
Right.
sequence.
Yeah, I mean, again, like sometimes, I mean, when we tried this in different example, sometimes it's really hard. Sometimes it took a while, actually. It took like 3 seconds or something. It's not like as smooth as you see in this example. But again, it really depends on like few variables, as I was saying, and also like the sample size. If you go on a larger scale, things could be slightly different. Yeah.
Got it. So we have a question from Richa. Like, how is the input data judged to be optimum, and which format is it?
Great question. Yeah, in terms of images, we kind of stuck to because we use pix to pix. That's the underlying algorithm we kind of used for our use case. I think pix to pix has like I think these are like PNG images in terms of format. In terms of size, I think it's like 256 cross 256. But then, for our exercise, we kind of tried different dimensions. Like we went for 512, whether to see if there's an improvement. And then we also changed the zoom, like the zoom levels of images. What happens if you zoom out a little bit or zoom in a little bit. But optimal thing, I would say, yeah, it's PNGs and 256 cross 256. That's good.
Got it. And also like that dimension is also helps in like if it's small, the inference time would be lesser if it's like high res.
Exactly.
To like when you were talking about Barcelona, like one thought I had on my mind, like what if like there is like a drop down menu where you have like train model of different cities, and depending on the image you could say, okay, Paris, like New York, like you can just select the train model and like try out different options.
Yeah, you're 100% right. I mean, that that is something we had in mind when we kind of started developing this kind of different impressions, right? You are in a certain place, maybe you are in Mumbai, right? I mean, and you wanted to have a drop down or of different fabrics. How Mumbai would look if you put a fabric of Tokyo or put a fabric of New York, or maybe put a fabric of China on top of it, or any city in China. So yeah, again, those are all in the process. But certainly achievable, because all you need to do is change the model, and then all you want to do is feed different kind of inputs for that. Yeah.
Got it. A question from Daniel is, can you discuss the pipeline for drawing on the web and linking to the model?
Yeah. As I was saying, I mean, I think I mentioned that it was quite a challenge for us to do all these things in the web, because again, as I was saying, this is just a demo we put together how things can look. But then when we tried things, what we had to do, export after the hours of training, we had to write a script to actually export that model. Something which can be conceived in the web. We use a library called MLJS. That is something which is quite helpful. So there you can actually, it also depends on the size of the model. So for that exercises, we trained pretty small area, and then we exported that into a model after training takes place. And then once you import that model in the web, there are different libraries you can use, like MLJS is one of that, I would say. And then once you import that model, then it's all in the web. That's how you communicate with the model once it's imported.
Nice. So I was exploring a similar workflow, and in that, because this train model on Google Colab are in .pkl or .pt file, you need to convert to if you're using ML5JS or TensorFlow.js into that compatible train model, and then you can communicate that. JavaScript can understand the language of train model.
Exactly.
And what are your future plans of machine learning developments in your group?
Yeah, I mean, as I was saying, research is such an integral part of Sasaki. I mean, we constantly try to focus ourselves in terms of what again, machine learning is one part of it. I mean, so we have in our team, a lot of people express interest to work on this kind of projects, right? But specifically in our industry, it's always a challenge, because I think it's still I think we are seeing few things, there's a lot of interesting things happening, but I think in terms of transforming that into real world scenarios, I think I would say there's still, I don't know, some time to reach there, right? I mean, so it's a challenge. It's a constant challenge we face. But I think the great promising things, what we are seeing is all this different kind of things happening around us in terms of I mean, this one is more in terms of generating this kind of impressions, more on a land level scale. I mean, but there are also other aspects to do with 3D data and all this kind of things. So again, a lot of things are happening. I mean, again, in terms of architecture, as I was showing in the art breeder or something, how 3D buildings can be generated, all this of isometric form. For us, I think one thing is to keep constantly checking in terms of what are the things that are happening in this. Again, as I was saying, VR is we closely collaborate with a lot of VR AR stuff. This is one aspect of it. In terms of this project, our next step is developing this as a finished tool at some point, so that people can try it out and use it out, and possibly to open source it. Because that's when we started this research, that's one of the things that I mean, even the pix-to-pix we are using, that's an algorithm that's open source. You can take that and then you can customize to how you want. That's the beauty of it. I mean, again, we constantly try to get some time and then do a routine check how far we can go on this.
I see. And like that's great. Like it's very rare to see architecture firms like open sourcing their like models. So that's great. Uh, like one thing which I like really like when we were having like a talk uh last time about like the user feedback in your process and how you manage like during development of tool, like how is the process of user feedback brought into the like the whole workflow?
Yeah, great question. Again, myself, I'm not like, my background is not in like architecture planning and more from the tech point of view. But then, having worked with these folks for the last 10 years, like kind of learned, kind of the nuances of how these things function, right? But then our group actually, we had a planner, we had a computational designer, and then, a kind of an overseeing principal, who is having planning background and software development background. And also we had a data analyst in our team, can also do like spatial analysis. Yeah, it's a small team within a team. So again, like this is like a whole company-wide thing. So, our team members are spanned across like different disciplines. Yeah, I mean, in terms of user feedback, I mean, apart from the user interviews and the literature reviews, the user feedback, we basically like, we saw like different scales of projects, happening across the firm. And then, we kind of went to the specific individuals, was playing this critical role in a project to understand, to do something like this, okay, are we asking the right questions, right? I mean, like, maybe, something already happening, right? I mean, or maybe it's like one of the really challenging things to do. Maybe it's not attainable in this kind of phase of this project because this project spanned across like 1 year. You have to be a little bit mindful of, how far you can go in terms of like, getting this kind of results, right? So yeah, I mean, we did user feedbacks in terms of, showing the model, and then like we also constantly, as I was showing like these different scenarios, because again, urban impressions is one aspect. We also did the study on land use land cover. We also did on repetitive pattern. If you actually take the Florida, the state Florida, I mean, like the housing pattern is like very repetitive, right? So we also did a study on that and how that the machines can generate like imagery, because machines are pretty good in making these repetitive things, right? So yeah, so all this when we did all the scenarios, we pulled in people even outside our team, in our firm to see, to get their feedback in terms of like, do we want to try something different imagery? I mean, we want to try maybe at a different scale. Yeah, I would say like that was quite helpful in terms of the shaping of the project.
Got it. And like this is the first time I'm asking this question like to a host. So out of like all the tools you developed, like was there any moment when you were like showing the tech demo or like implementation of the tool and see like the client like, oh, this is like game changing or very satisfactory moments?
Wow. Yeah. That's a super interesting and a big question to answer. I would say yes. I mean, definitely, especially when we do. It really depends on the client too. I mean, like how whether some clients are not that tech focused. They really wanted to see like what is applicable for them to see. But yeah, I mean, I've seen like really fascinating moments with the clients in terms of like as I told you in the beginning, like data visualizations, space moves, like VR or gamifications. I think yeah. I mean, I think the process, even though they really like the process, I think the end product kind of sometimes makes the difference, right? I mean, like what do you actually see it in the end? Something they can take it and then like they can use it after that. Definitely yes. I mean, there are a lot of moments which I can point out, but yeah.
Got it. And like one thing I see in the industry is many times like architecture, like techies develop tools, and uh, sometimes the tools has larger adoption in the company, sometimes it's lesser. So like, are there any like advice, a piece of advice you would like to share to architecture developers, that while developing the tools, how to keep like end user in mind, and like ensure like it's making an impactful like yeah.
Yeah, yeah. I think, yeah. I mean, like one thing we found it really useful. I mean, in terms of like the client or the end person who uses it. I mean, like we really focus. We also have like UX UI person in our team, so we certainly give a lot of importance to how the end product should look in terms of it has to be because there are like because we are moving into the mobile world. I mean, like a lot of things are very mobile based apps. Like, it doesn't have to be an app, but it's still like a website or something which can load in a mobile and still it should work. So we take a lot of things into consideration in terms of usability. Whether it's like using mobile or whether it's using desktop, things should be really usable by the end users, right? And there shouldn't be any clutters or there shouldn't be any like some weird thing happening when you load a website or something. We constantly strive forward for that. And in terms of technical side of things, before I reach to the the end user, or speak a little bit on the technical side of things, which is like um, again, it's a very let's say it's a group effort which we had in the team in the sense that as I was saying, once we started moving into this React world, right? I mean, that we wanted to address things like modularity, extensibility, reusability, and also we do a lot of code reviews in our team, because when we develop this kind of projects, as you see, if you go to tech firm and you see like they follow this one of this agile model, like sprint planning, all those kind of things. So we do all those things in our process because I think we kind of believe if you have the right process, you would and then you constantly make an effort to have the right process, then definitely you're going to see the right results. So that is something we constantly strive forward to do. That really helps to actually not to to use our time in an efficient manner and not to again build something from scratch which you already did, right? In terms of end users thing, I think once you do these kind of things, I think the user in most cases they're pretty satisfied in terms of using the tool, right? And addressing the problems they have.
Got it. uh I wish the technical discussion go on and on, but I just realized like I just lost track of time. So I'd like to like end the interview with few light questions. So Raj, how does a day in your life look like?
You mean outside the work? Yeah, I
Sorry?
mean, I was asking like, is it like, in a when I work, or is it like outside the work?
Like work day.
Work day, yeah. Well, I mean, like this is quite challenging time, right? What we live in, it's all like, we're all like working from home. Again, I have to maybe answer that in two different ways. Like, during the, the non-lockdown phase, which we were before, I hope we return back to normal quite soon. I think it's pretty close, but yeah, fingers crossed. Yeah, normally, I mean, I think I'm usually a person, usually very kind of a night person in terms of, I don't wake up like too early, even though I try to do that these days. But then again, like, going to work, having a, cup of coffee, that's usually my first thing. And then like, you usually have like a lot of this water cooler chats, from really like, I mean, I sometimes like, a gym, this idea kind of happens there during this water cooler conversations, which we right now miss because of this virtual or lockdown work or remote work. But in terms of daily activities, it really depends. But I think, as I was saying, 50% of the time, I usually like engaged when, like heads down work, okay, let's get this thing done. Have your check-ins with the team members. on seeing or like overseeing, like, in terms of deliverables. We constantly have this kind of deliverables like every couple of weeks or every week sometimes to different plants. And yeah, I mean, and then I usually sometimes go away from the desk and then, like, go to the review which we have at the office. And then, I usually do the heads down work there, like go there somewhere and, like, focus on in a couple of hours and get that thing done. But in terms of, yeah, I mean, in terms of the actual work or something, as we we're saying, I do code like 50% of the times, and then the rest is scattered, like managing a team, and then, like, doing this kind of code reviews or organizing those kind of best practices thing for the team. Those kind of things. I don't know if I answered your question, but
No. It gives like a good perspective of how your time is spent in managing things, coding things, and like activities you do. So, any book or mentor which made a big impact in your life?
oh wow, so many. Uh, the book, I would say, yeah, something which made an impact, I would say, is like, I would say like maybe one or two. One is the biography of Steve Jobs. That was by, I think, Isaac from Isaac Water. So that was quite a book to read. I mean, like, it starts from from an early age, the struggles, and then, like, how the curiosity kind of turned into a small firm, and then, like, how, again, it's a journey. I would say, yeah, that book was quite motivating for me. Again, like Alchemist, again, like completely nothing related to tech. I'm just saying, in terms of, just in terms of books. In terms of mentorship, I think I draw things from different folks. Like, as I was saying, being in this tech world, I mean, even though I'm the planning and design industry, more on the tech side, like Steve Jobs, and then other folk. I mean, like right now, if you say like Elon Musk, all these folks make a quite big impact. I mean, like going a little bit further in my childhood days, like, Mr. Abdul Kalam, he was a president of our nation. Now I even read his book, like Wings of Fire. That was quite motivating. Yeah, I mean, again, like, I draw, motivation from even, like, really some minor things which can impact your life, even, like, from common man, when you go on the street, and yeah, drawing inspiration from, I think anyone is quite fruitful in terms of, I think it really helps in the learning process, because I am someone who thinks like there's always something to learn from anyone, right? There's no limit to learn. So, but in terms of, like, like some bigger motivations, these are some of the. I know I'm missing like a lot of folks, but I think these are some ones that just quickly come to my mind.
I see. Interesting. And like, any place to travel on your bucket list?
Yes, New Zealand. Yeah, New Zealand is one place. I don't think. There's need to be some definite planning need to be done for New Zealand. Yeah, and then, like, I'd say, yeah, to name one, New Zealand. Yeah.
I see. All right. So I know we covered a lot of interesting things in this talk. Anything which you wanna add or say which we didn't cover?
No, I think I want to say, like, thank you for thanks for the audience for listening. I think, and especially thanks, Myron, for kind of putting this together. I think it's a very different experience for me because normally doing presentations, sometimes it can be very formal. I found this like really this medium has been like really very conversational and very interactive. I really liked the back and forth Q&A things which we did during the presentation. But again, like on a lighter note, how we kind of chatted about like a few offline things about apart from the professional things. Yeah, I really liked it, and again, like thanks so much for having me here. It's a great experience. I continue to again, like we continue to somehow connect with these things. I'm hopeful of that. Thanks again.
Thanks a lot, Raj. Like I learned a lot and like it was quite insightful. So
Same as well. Yeah, I mean, learning on this side too. So.
okay, that's it for the show. Thanks everyone for joining. Have a nice rest of your day. Bye-bye.
Bye. Thank you.
Yeah, one last thing, Raj. So there was a question like, how can people follow your work and update on social media?
I would say like it's a LinkedIn. Yeah, LinkedIn is somewhere like I do post a lot of things. And apart from that, yeah, I would say that's pretty much it. In terms of like the work, LinkedIn is the one main thing. I mean, I also have like a Medium link, which I sometimes post in my LinkedIn, but I say LinkedIn. Yeah.
Okay, I shared your LinkedIn profile link in the chat. Awesome.
Yeah.
Bye.
Bye bye.